In this video, we're going to talk about the volume of the solid. We used the integration to find the area between two curves before. Now we're going to try to use the same idea of integration in order to find the volume. Okay, so you're going to see that in this picture, you have a solid S. So normally we're going to call this solid S. So this solid S that you have here turned out to be the solid that lies over the interval AB. Okay, so you see that it's lie between the interval AB. And we would want to compute the volume of this solid. Okay, so we would want to compute the volume of this solid. The way to do is going to be we gonna subdivide the interval AB into many pieces that we have here. And you see that we're gonna have the solid that you're gonna see the cross section and you're gonna see the width of the solid. So the width of the solid turned out to be the delta x. So it's going to be xi minus 1. And you're going to see that you have the cross section. And the cross section turned out to be axi. So we'll be able to find, like I said on the handout here, we calculate the volume of a solid by dividing the interval AB into n small subintervals such that each interval has the volume axi star. So this one is going to be the cross section. Okay, so this one will be the cross section. And you have the delta xi, and delta xi is the thickness of each piece. So it's going to be the thickness of each piece. So for this one, I like to enlarge this picture for you a little bit. That you see that this one, you have the thickness equal to delta xi, and you just pick one number for xi star, and this one is your cross section. Let me use other color. So this one, so this guy is cross section. And in order to compute the volume, okay, the cross section gonna be, you have to be able to find the area of the cross section. So this one will be area equal to a xi star. Okay, and you gonna compute the volume of this small piece given by the cross section. So this guy is area of cross section. Okay, and here this one will give you the thickness. So you see that you have this volume first, and then you're gonna sum the volume up. Okay, so you're gonna see that you have the volume of the small pieces and you sum them up. So the thing that you will obtain turned out to be the thing that look like that we used to call the Riemann sum. Okay, so I'm not gonna write is in here. So it's going to be the Riemann sum first. So you have the Riemann sum like this, and you're going to take the limit and go to infinity of this number. That means you divide the interval into many pieces. And this one will give you the volume that you're looking for. Okay, and in terms of integral, this guy turned out to be the integral from a to b of ax dx. So I usually tell my student that if you want to work the volume of the solid over the interval AB, the thing that you need to do is gonna be you gonna integrate the cross-section area. So it's gonna be integrate area, you get the volume. Okay, so we're gonna integrate area. So we're gonna integrate area, it's gonna give you the volume of the solid that you are looking for. So we're going to keep in mind it's going to be integrate the cross-section area. Okay. So for this one, you're going to have the volume of the solid as V equal to integral from A to B of ax dx, where ax is the cross-section over the interval AB. Okay, so it's going to be, you have the plane P and you're going to cut your solid, and you're gonna see that you're gonna have the volume of the cross section. Okay, so let me point out your AX first. So here you see that I point out the cross section. Okay, so this is the thing that you are having. And you see that, hey, this picture not have thickness. When enlarged, okay, like I said, you divide the interval AB into many, many pieces, the thickness turn out to approach zero. So it's gonna look like this. It's like you integrate the cross section area. So the picture here shows you a braid that you see here that is going to be your thickness. Okay, so you see this one is your thickness. And if I put the x-axis and y-axis for this picture, let me put the x-axis and y-axis for this picture. So for this one, you see that this one is my 0, this one is my y, this one is my x, and this one is over the interval AB. And you see that this one is your delta x. Okay, so it's going to be your delta x. And delta x come from xi minus 1, and you have your xi like this. And you see that this one, when you compute, is going to be the volume, let's say VI. So you see VI is going to be just AXI star, and you have delta X. So this one, you're going to get the volume of the pink pieces like this. And then you're going to sum. Okay, so you're going to sum the volume up. So you're gonna sum the volume of the pieces. Let me write it down. So when you sum this one up, okay, so this guy turned out to be the sum of a xi delta xi, okay, and this one will be the volume that you have for over the interval AB. Okay, so this one will be the thickness or something. Okay, so this one is going to be like the idea. So now when you look at a loaf of bread like this, you see that if you like to compute the volume of the whole loaf, you're going to just compute the volume of each slice, and then you sum them up, you obtain the volume of the whole loaf of your bread. Similarly, we'll be able to integrate with respect to y if you subdivide the interval along the y-axis. So we have like two choices. You can integrate with respect to x when you divide, or when your solid is lie over the interval AB in x. However, if your solid turn out to be vertically, so you're gonna so when you have your solid vertically, so you're gonna integrate with respect to y instead, and you're gonna integrate over the interval of y, and it's normally we're gonna write it in terms of c to d. Okay, so let's do one example. So you like to compute the volume of the solid, okay? That is gonna be circular base of radius 1 and parallel cross section perpendicular to the base are equilateral triangle, and we gonna find the volume of the solid. So you see that you like to find the volume of this solid, and the base of your solid in 3D is gonna be a circle, and you know that this guy has equation x squared plus y squared equal to 1, which is a unit circle, okay? And you have the cross section. So this one is your cross section is equilateral triangle. Okay, so this one, the question gives you that this guy has the picture equilateral triangle. Okay, so it's turned out to be equilateral triangle, and you have to find the area. Okay, so you have to find the area, but first of all, let's see where you are having A and B. So you see that if I enlarge this one, you're gonna have A to B, which is the interval where your solid lie above. So you see that your solid lie above the interval AB, and in this case, your AB turned out to be negative 1 to 1. So this one will be your A and your B. Okay, so you have this interval A to B like this, and you're gonna integrate this area of the triangle. Okay, so you know from the calculation that volume equal to integrate from negative 1 to 1 of the area of your cross section. So it's gonna be area of the equilateral triangle, and you're gonna dx. Okay. So the thing that we need to compute turn out to be the area of the triangle. Okay, so we need to compute the area of the triangle. So in order to compute, let me write down. So we need to compute the area of the triangle ABC. Okay, which is going to be our cross section. So you see that this one, you need the side here. Okay, so you see it's gonna turn out to be, you need to compute the side of not the side, the length of AB. So here you have the area of the triangle ABC. So it's gonna be equilateral triangle. Equilateral triangle. And this guy, if you recall, if you have equilateral triangle, let me draw one picture for you. So if you have equilateral triangle, you're gonna be able to compute the area by, okay, so area will be equal to the square root 3/4 s squared. This is the formula that you study when you study trigonometry or you study geometry from your high school, that you know that this guy will be like a 60 degree, right? So this one is 60. Okay, and you'll be able to use trigonometry in order to use sine and cosine or something that you'll be able to derive this formula. So it's going to be the area equal to square root 3 over 4 s square, which is the side of equilateral triangle. So for this one, it's gonna turn out to be square root 3 over 4 of absolute value of AB square. Okay, so you need the length of AB. Okay, so you need the length of AB. In this case, you see that A has the coordinate x, y, and B will have the coordinate. So you have x here, you put your x here. Let me, you put your x here, and you're gonna have your y here, and you also have your negative y back there. Okay, so why do I know that it's going to be negative y? Because it is circle, so it is symmetry. So you have y, negative y. So at this point, you have a xy, and you're going to have b, which is x negative y. Okay, so you have x negative y and axy. So what will be the length of AB? So you have your point x here, okay, and you have here. So let me explain. So this guy will be the length of AB, and the length of AB turned out to be y minus y, and it's going to turn out to be 2y. Okay, because you see that this one has the length equal to y, this one also has the same symmetry, so it's going to be y. So it's going to be, you're going to add them up, so it's going to give you 2y. Or you can just find the distance from y to negative y, so it's going to be y minus y. So it's going to also equal to 2y. Okay, so you can see that in two ways. So in this case, you get this one is going to be root 3 over 4, and you have 2y squared. Okay, right. So for this one, let me, so this guy is equal to 2y for AB. Okay, and then what? And then you need this guy, which is your AX. Okay, so it's going to be your AX. So you need y in terms of x. Okay, so change to x. Let me write this one. So you need to change to x. So you need to know root 3 over 4 to y squared in terms of x. So you're gonna just have root 3 over 4 to y squared is 4y squared. And you know y squared here, that, so you see x squared plus y squared equal to 1. In this case, you're gonna have to solve for y squared. Okay, so you have y squared equal to 1 minus x squared. So this one is y squared equal to 1 minus x squared. And you're gonna just get rid of 4 and 4. So it's gonna be root 3y squared. So it's gonna be root 3, and you multiply with y squared. What is y squared? Y squared is 1 minus x squared. Okay. So this one will be your area. With me so far? The thing that I did is I tried to compute the area of the cross section, And in order to compute the area of the cross-section, you have to know the formula for computing the area of the equilateral, because your cross-section, the triangle ABC given in the question, is equilateral triangle. And you see that you like to compute the area of the cross-section at any x. So you see you have your x here, and you like to measure the length of AB. So you're gonna get 2y for the length of AB. So you get root 3 over 4, 2y squared, okay? And you're gonna change everything in terms of x. So you have y squared, which is equal to 1 minus x squared. So you get root 3 times 1 minus x squared. So this one will be the area of the cross-section AX that you are looking for. And for this one, okay, so you have AX equal to root 3, 1 minus x squared. So for this guy, it's gonna be integrate negative 1 to 1 root 3 1 minus x squared dx. So this one is the pink color. Okay, and then you're gonna just integrate this number. So this one is gonna be, let me integrate. So it's gonna be square root 3, and you integrate 1 minus x squared, so you get x minus x cubed over 3 from negative 1 to 1. So it's gonna be root 3, and you have 1 minus 1/3, subtract negative 1 minus 1/3, okay? Okay, and then you evaluate for numbers. So it's going to be root 3, and you have 1 minus 1/3 is 2/3, and you subtract another negative 2/3 for this guy. So it's going to be 4/3. Okay, so it's going to be 4 root 3 over 3 for final answer. Okay, so this is how we compute the area of the, sorry, it's not going to be computing the area. You integrate the area, you're going to get the volume of the solid that you have here. It's going to be the cross-section is equilateral triangle, and it's going to be the base is a circle, and you'll be able to integrate over the interval negative 1 to 1, and you obtain the area. Sorry, obtain the volume. The next one, the question asks you to compute the volume of the cone whose base has radius r, and the height for this cone is equal to h. So if you draw the picture, so you have a straight cone. Okay, so let's try to first illustrate the picture. So you have this guy, okay, and you have, I like to try to draw a cone, okay, so you have a cone like this, and I'm gonna put the x-axis and the y-axis for this cone. Okay, so you have y, you have x, okay, and you see that this one is the cone with radius r. So let me put r somewhere here. So this one is gonna be r. So this one gonna turn out to be r on the x-axis. And you have the height equal to h. Okay, so the height here will be equal to h. Okay, so this point turn out to be your h. Okay, so this point turn out to be to your r h. Okay, let me it's kind of confusing. So you have H here, okay, and here is gonna be your R. Why don't I use different color? Okay, so that should be clear enough. Okay, so you have this picture and you're gonna compute the cross section. So you just have the cross section. So the cross section, let me use this one. It's okay. So the cross section turned out to be this cross section. Okay, so as you can see, I have this cross section here. And the area of the cross section, you see that you use the subdivision. So we're gonna subdivision from 0 up to h. Okay, so you're gonna subdivide 0 to h. So here you subdivide along the y-axis. So you have the y-axis here, and you're gonna subdivide this thing from 0 up to h. So it's gonna be, you're gonna integrate from this 0 and you're gonna stop at h. Okay, so the volume turn out to be integrate 0 to h, the area of circle. Okay, and your circle will be your circle center at y, right? It's going to be center at y, and you see that this point is the point xy. You're going to project this one for your x. Okay, so you have circle at the center at y, and it's going to be dy. Okay, and you see that the radius of your circle, the radius of your circle here turn out to be equal to x. Okay, so it's going to be this circle. And you know also that the area of the circle, radius x, okay, so radius equal to x, the area will be pi r square, so it's going to be pi x square. Okay, so this one, your x is the radius. Okay, so you have the radius of your circle given by x. Okay, so just the point xy. However, xy is on this line. Okay, so xy is on the yellow line. Okay, so we need the relation on x and y. So we need the relation on x, y. Okay, we know that xy lies on the straight line, the yellow line. Okay, so we will find the equation is equation. Okay, so in order to find the equation of the yellow line, you see that this yellow line passes the origin. The origin is 0, 0, and you have the RH point here. So you're gonna find slope will be h minus 0, r minus 0. So it's gonna be h over r, and you just use point slope form. So you're gonna just get y equal to h over r times x. Okay, so you're gonna get x equal to r over h times y. Okay, so this one will give you the relation between x and y. And why do we need this relation? Because you know x equal to r over h times y, and you have your x, you have your x square. Okay, so this is you have, so we're gonna put this guy to this x. Okay, so you're gonna have the volume equal to integrate from 0 to h of pi, and you're gonna put r over h y square and dy. Okay, so this one will give you the volume, and this guy is the green guy that I just put in the place of x. Then what? Then you're gonna integrate. Okay, so you're gonna 0 to h and pi r square over h. Okay, and you have y square dy. I forgot s square down here. And so you're gonna just pull out pi r square over s square, and you integrate y square 0 to h y square dy. So it's gonna be pi r square over h square, and you integrate y dy, you get y cubed over 3 from 0 to h. Okay, so you get pi r square over h times h cubed minus 0 cubed. Okay, so you would compute the final answer that you get pi r square. Okay, so you get pi r square h, and you have over 3 because you can cancel h square with h cubed here. Okay, so you just have h left. So you get pi r square over h square cancel with h cubed, so you get pi r square h over 3. And this is the thing that you have learned in high school before, that the volume of the cone, the straight cone, turned out to be 1/3 of the volume of the cylinder of radius r and the height equal to h. And we be able to use calculus in order to show this formula. Okay, so this one is nice for computing the volume. And the key idea is going to be just your first step. Your first step here is you have to understand that the volume turned out to be the integral of the area of the cross section. So the key step that I like to emphasize is here. Okay, so this one will be your key step. Okay, the first step. And the second step, you're gonna find the relationship between x and y that will allow you to be able to compute this integral in the third step. Okay, so this one you compute the integral in the third step. Okay, so that's all. Okay. The next example that we're gonna study is gonna be the volume of the solid. However, in this one, the base is the parabola x squared equal to 4y and the line y equal to 5. Okay, so let's draw the base first. So the base that you have here is gonna be x and y, and you're gonna have your parabola. Let me draw it like this. So you have x squared equal to 4y. So it's going to give you parabola. x squared equal to 4y, okay? And you have the line y equal to 5, y equal to 5. Okay, so you have the line y equal to 5, and you have this intersection here and here, okay? So you have y equal to 5, which is the horizontal line. Let me enlarge so I can see clearer like this. Okay, so this one will give you the base of your parabola. So this one will give you the base of your give you the base of the solid. Okay, so this one will be the base of your solid. And you're gonna sketch this picture in 3D. So this one is 2D, right? So this one is your vertical, is your Y, and you have your X here. Okay, so let's draw this guy in 3-dimensional. So if you want to draw this one in 3D, so this one is gonna be X, Y, and you have the Z axis. So for this one, you have Z, you have X, and you have Y, okay? And you see that you're gonna have X back here, like this. And you have the the parabola is gonna be on the floor. So it's gonna look like this guy, okay? It's gonna look like this guy, and it's gonna look like this guy. Okay, so you have the parabola on the floor like this one. And you have the line y equal to 5 will be this straight line. Okay, so this one is y equal to 5. So you see that you have this picture in 2D. So it's going to be in 2-dimensional. Here, when you flip this one on the floor, this is the same picture. Okay, so this is the same picture. And you have the cross section perpendicular to the y-axis. So you see your y-axis is here. Let me emphasize this one. So you have your y-axis here, and you have the cross section perpendicular to this y-axis is a square. So the picture give you in this way. So you're gonna have a square here. So I'm gonna draw a straight line. Okay, and you see that I have a square. What does it mean? It means that you're gonna have this one together with this one, and okay, so you get this square. Okay, let me move the whole picture down. So you see that I don't need this space. So I need X here, and you see that this is our square. Okay, and you're gonna integral. Okay, so this one is your Y. Okay, so you're gonna integrate from Y equal to 0. Okay, so you see that you're gonna have the volume equal to, so you see if you have this picture, you see that the volume turn out to be integrate from 0 up to 5. See the color. So it's going to be 0 up to 5 of the area. Okay, so it's going to be the area of square dy. Okay, so it's going to be the area of the square dy. Let me enlarge this guy a little bit. So it's going to be the area of the square, right? So it's going to be this square and dy. So you need to know that this one will be the point x, y, okay, and your x is here, your x is here, and on the other side it must be negative x. Okay, so you have x and negative x, and for this point it's going to be negative x and you have y. Okay, so you see this one in 3D, and this guy will be your xy. Okay, so this guy will be your xy. So you see two important points here. So you have your xy and negative xy. Okay, and we like to measure the length. Okay, so let me highlight this one. So the length of this line, okay, so you see the yellow line, the length of this line turn out to be equal to what? So you like to measure from here to here. The thing that you see is going to be, hey, it's going to be x here, right? And it's going to be another x here because of symmetry. So you sum this guy up, so you would get 2x. Okay, so you see you have x for the length from 0 to x, and you have the length for 0 to negative x also equal to x. So when you sum them up, it's going to be 2x. So what does it mean in this case? It means that the length that you have here is equal to 2x. Okay, so let me write it down clearer. So this one will be equal to 2x. Okay, and you're gonna put here, it's gonna be 2x. And because this guy is a square, so you get 2x for the height as well. So you get 2x and another 2x. Okay, so the area turned out to be 2x square. Okay, so let me move this guy. Okay, so this one will be integral from 0 to 5. Okay, and the area of this square turned out to be 2x squared. So let me write it in red. Okay, and it's gonna be dy. Okay, however, we know that this guy has equation x squared equal to 4y. Okay, so this one will be integrate 0 to 5 to x squared dy, not to 4x squared dy. Let me write in this way, it would be clearer. So for this one, you have 4x squared, okay? And you'll be able to change x squared to 4y. So it's going to be times 4y. And you have x squared equal to 4y here. So you have x squared change to 4y, okay? So in this case, this guy is going to be 16y, okay? So the integral that you are integrating is going to be integrate 0 to 5 of 16y dy, okay? And you get 16y squared over 2 from 0 to 5. So you're gonna get 8 5 square minus 8 0 square. Okay, and so it's gonna be 200. Okay, so 8 times 25, it is 200. So you see the thing that we did is very simple if you know the first step. So the first step is the key thing, like I said before. So the first step is you have to know that the volume turned out to be just integrate the area of the cross section. and you determine the area of the cross section by maybe you have to graph this one a little bit in order to compute the area, and you may have to use your imagination in 3D what's going on a little bit on that guy. And after you know that the area is 2x squared, you're gonna have to change x to y because you are integrating with respect to y. Okay, so you'll be able to change by just see the relationship between x and y on the parabola. X equal to, not x equal to, x squared equal to 4y. And it's gonna turn out to be this one for your final integration. Okay, so this one is called the volume of the solid. Normally, this one is called cross-section method. We're going to apply this one in the next video in order to compute the volume of the solid by revolution. So it's going to be, you have the graph and you're going to have the area and you're going to rotate that area to obtain the solid S, and you're going to cut it and you're going to see the cross section turn out to be circle, and that is called the volume of the solid by revolution. That is going to be on the next video that we gonna study.